off my laptop.
Oh, okay.
And then we'll make sure that we're appropriately
When I say
live.
other side of Russia, I mean the other side of Russia. Overalls.
Yeah.
Way up over here.
Yeah, where it should never.
Where it should never have been in the first place.
Right.
We don't know how. And somehow the guy wound up with two of them. Somehow. It's not cheap.
Right.
There's our, my wife is Lithuanian, and I kind of, I said, I just bought a laptop that shouldn't exist. Formerly in possession of the NSA, and it wound up over in Russia. And I said, where? I said, oh, your eyes is kind of crazy.
I'm trying to verify the audio off the live stream.
What's up here?
If you want to, I mean, we want to like check that on your phone real fast and see if you hear the audio on my live stream. That'd be great.
Okay, awesome. Yes, I will.
Is it on your?
Yeah, it's on the Texas Airhouse channel. Just see if you can go into the live stream and make sure you hear the audio.
That will see a lot of people.
Because that would be a bummer if we missed the audio like we missed it last time around.
I don't know. I'm literally just going to be improvising this.
Oh yeah. That's totally fine. Okay, well it'll take a little bit of a delay before it comes to you.
What I said in that video. Here's audio.
Here's audio, okay, good.
Okay, can I, you want me to introduce you?
Yeah, go
When I
for
do
it.
the whole introduction.
Yeah. Why don't you step over here? The number get your water, I think this was the bigger one.
Guys, I'm going to close the door.
Okay.
We're gonna find out.
All the time.
All right, folks, so this is our second try at, second time doing the lightning talks. We have a couple really, really nice ones lined up today. Lots of interesting stuff to see and think about. First up is Stephen Wylie, and he's going to talk about his 4004 adventure. I guess it's more than just the project itself, so you're in for a treat. Here we go.
Hello everybody, and I'm here to talk to you about an adventure with building a calculator using Intel's 4004 processor. Now, for those of you who are not familiar with the Intel 4004, it was basically Intel's very first microprocessor design, and also the first commercially available design that could be purchased by itself and not in the context of some other computer or some other large set of chips to go along with it. So basically the project originated back in 1969 when the Visicom calculator company in Japan said, hey, we want you guys to come up with a chipset for us for the upcoming solid state chipset design calculator. But Intel said, okay, that sounds all fine and dandy, but to do all these logic chips, to do all these interconnects, it's going to be extremely expensive back then. Not only that, too, we really don't have enough staff to go on and design umpteen logic chips and get all these things fabricated. So they said, let's think about this a little bit more creatively. And they decided to come up with a general purpose CPU that utilizes instruction sets and kind of like pipelines and such to perform instructions. So what you have is Federico Fagan kind of took over the project at a time after they kind of got distracted doing stuff for Control Data 2200 stuff. And he actually put it out there, I think it was April of 1971. So by the end of the year, basically Visicom said, okay, hold on a minute, we're not doing so well financially. So why don't we reduce the price of this chip? That would be great. And Intel said, okay, but to do that, we are going to want to back out of our exclusivity agreement with you guys to only have this chip in our calculator and say, and we'll sell it to everybody. Okay, cool, now everybody can buy the chip. $60 for the Intel 4004 back in 1971. It's about $360 nowadays. So, you know, I guess not too much money in the context of what you might spend on a processor. It's about kept up the same. And so after this is all said and done, now Intel's stuck with, okay, well, how do we market this thing to companies across the world? And they thought this was a huge challenge for the marketing team to describe something so novel and innovative, but they eventually managed to do this thing, especially with some of the side projects they had running by then, like the Intel 8008 and 4040. They were able to come up with some really compelling products to drive microcontrollers as well as terminal computers and various other I/O devices, and so they really came up with a strong line of things and sold these very well throughout the 70s. What's interesting though is that Intel itself was really a memory company prior to 1971. They did a lot of memory chips that were very popular, but now they became known for originating CPUs. And interestingly, Federico Fagan became one of the founders of Zilog Corporation in 1974, so it became the makers of Zilog Z80. So there were a lot of great things that came out of his mind after everything was all said and done. Now, the 4004 in and of itself might be a little bit difficult to use without some additional supporting chips. And so for this, you see this MCS4 development kit board that they would sell. And along with the 4004 on this board, you had a 4001 mask ROM, which essentially, as the purchaser of this type of system, you could specify to the factory which ROM you wanted programmed. They would just make it for you straight from the factory. Pretty cool, except maybe not so useful in modern era because you don't know how their computers are designed anymore. So it'd be difficult to use a 4001 anymore. 4002 RAM, which is kind of cool, it contains 256 words of addressable RAM, and each word is only 4 bytes, so basically 128 bytes of RAM. Plus you get additional 64 words of status characters for each particular group of memory. So really like 320 words, 160 bytes of RAM in each of these 4002 chips. You can link together a bunch of 4002 chips that would make up a 16K if you really had the budget for it. And there's a 4003 shift register. Shift registers are basically a really cheap way to emulate RAM. You can obviously spin the shift register as much as you want. You can access something else and put it back on the stack if you need to, or else you get rid of it. But if you wanted to go fancier, you could also go along with the 4702A reprogrammable ROM. I'm sure that's a lot more money than just getting the ROM burned for you. It's just, you can't ever edit that ever again. Also, there are some 4008, 4009 chips for I/O expansion that came with the MCS4. Now, what this thing ended up looking like by 1973, it had this MCS4 Mod 40 system as the Intellect. And these Intellects are extremely capable. They were able to have debuggers, compilers, assemblers, and even write languages that were beyond just assembly. You could put on some sort of higher level language with that. It might have been like BASIC or Fortran, who really knows. But now these things were retailing in 1973 for like $2,800. And if you look at Price is Right episodes from 1973, that was the price of a car on the show. Like a Chevrolet Vega was running about $2,800 back then. So you could have a car, or you could have this amazingly awesome dev kit. And of course, in 2 years, you could get a Altair 8800 as well, and like probably for a lot less money. I don't remember what those retailed for off the bat. But in the modern era, because these Intellects are going to be very hard to find, they only made a handful of them, probably highly sought after by collectors, worth many tens of thousands of dollars. Now we've got some folks that have decided to essentially step back and reverse engineer everything, and make their own little modern computers to go along with the Intel 4004 and the 4040. So you can get these boards off a CPU Shack from eBay, and you can look at the website about them on CPU Shack, and they'll redirect you to eBay with the actual link to go buy them. And it comes with a 4289 for the I/O expansion and memory addresser. So basically that replaces the 4008 and 4009 from earlier. 4289 is actually pretty robust and lets you do everything fairly easily with the rest of the supporting chips they've got on the board. And also you can use a 28C64 ROM to configure a couple of different programs on there if you want to. You can load one side of the ROM or the other. You can address each one with a switch. You can, on this particular board, switch between different programs if you want to. All you have to do is provide your own 4004 or 4040, in addition to a 4002 memory if you want to. And so, in addition to these capabilities of the chips, you have 8 output LEDs, and you can address 4 of these LEDs at a time by selecting a particular output line. And then you can also do 4 input buttons by selecting the particular input line off the system at the time that you are looking to address the LEDs or the buttons. So, that having been said, all this stuff was acquired through kind of late 2018, early 2019, I guess. It seemed interesting for me at the time to, even back then, write some kind of program for the 4004. I wasn't quite sure exactly what back then, but it seemed interesting to try to learn this stuff. And so I went looking around on eBay for where I could get these things. Unfortunately, I was able to get the 4004 plus the tester for only $130. This is only like 20 bucks more than they're selling the CPU Shack boards for. And just so happened to find a guy that was selling a 4004 for, I think it was like, he wanted 100 bucks more than he was going to throw on the board for like an extra 20. I don't think he knew what he had or something like that. So you know how that goes sometimes. Got lucky on that. Did not buy a 4001, because what's the point? The 4002s, I was able to get 2 chips for 36 bucks total, and the 4003 shift register was $58. So, you know, take this as you will. Whatever prices find that nowadays, you might see better or worse. Obviously, you might look at these things and feel like, oh, you're an idiot, you spent way too much money, but who knows? I haven't looked since then. So, what's cool about this is the entire board for this computer is a schematic on Altium Designer, and you can get in touch with the fellow that made this thing on cpuworld.com, which is a forum, and he was gracious enough to email me the whole schematic and PCB documentation for this file. What's really cool is that this file is an Altium Designer file, and Altium is a CAD program. It actually has a free online viewer, so I can go into a Chrome browser tab, and I can just mouse over one of these lines, and it actually will highlight where this line appears in the entire rest of the schematic. So as such, it's really, really cool for just quick and dirty schematic viewing. And I think I've not used Altium personally because I haven't really been doing any PCB design in several years. But I think if I did, I would strongly consider going that route, just from the standpoint of sharing designs with people without them having to have some sort of expensive or inaccessible software pack that only runs on particular PCs or what have you. So it's really very cool. I can just open up a Chrome tab, upload the schematic, and there we go. Just start mousing around it and seeing various aspects of it. So, of interest, you can see there's several of these chips. The 4 I/O lines are up here on each of these 74. I think there's a 161 chips, and they drive the output from the LED. You got 74 125 chips acting as the buffer for these buttons. And so there's 4 buttons, and the chip select lines all come from up here on this part of the schematic. And those chip select lines are driven by these I/O decoders, which are going to take a particular memory address that you've loaded up into certain address lines on 4289. And it's going to say, okay, you actually want to talk to inputs 1 through 8 or outputs 1 through 8. Of course, this can actually address 16 as the entire system, but the board is only designed for doing 8 at a time. So obviously there's some limitations with this particular PCB, but for general purpose stuff, it's really very good, and you have a lot of chance to expand the types of input and output that you've got. Now, the next piece of this, besides the hardware aspect, is the software aspect. So besides understanding all about this computer platform and how all the I/O is supposed to be laid out and work and addressable through the hardware, now you've actually got to write the assembly instructions to make a calculator. And not just doing stuff like addition, subtraction, and so on, but also to consider driving the display. So how do I write out to the VFD display that I'm using? How do I drive input from a keypad? And what does that all look like? You know, how am I going to collect the signals from exactly which button's being pressed? And then stuff like, okay, so as people press keys on this thing, it can only go so far before it needs to roll over and overflow. So how do I address rolling over and overflow? How do I lay out the memory in such a way where I can quickly say, use all the numbers and then have them up and multiply them together? So a lot of other things that go on into writing this program, other than just the basic 4-function calculator aspect. That's really all I'm going for is 4 functions incidentally. I wasn't trying to do any square roots or exponents or anything quite that well. And not even any floating point either. Obviously, the Visicom calculator did have floating point originally, I think, but I am not that masochistic on myself. I don't have that kind of time implementing that junk. I remember going through the pain of building an ALU in one of my graduate level computer engineering CAD classes where I had to build IEEE 754 compliant ALU. Nuts. All that stuff. So no, not doing it here. So in programming the Intel 4004, let's talk briefly about the instruction set. This is it, guys. This is the entire instruction set of the 4004. I'm pretty sure this is 48 total instructions. And what you're finding, that there's a bunch of these things that are kind of relevant to the system at hand that you're not going to see in other systems. Like these are things for reading and writing the status characters of various RAM chips that exists in your system. There's things like a keyboard process. So how do you take inputs that might be 0 through 16 and make them only one line at a time? And there's other sorts of kind of strange ways the instructions are laid out. One thing you'll notice is that there's no Boolean instructions at all. So you don't have this concept in your chip of doing ands and ors and XORs and whatever else. And so there's not that convenience for it. You have to figure out how to do it yourself. So to go down the line here, we already talked about, I think this is a 4-bit processor because the data width is only 4 bits. You do get 16 of these 4-bit registers, R0 to R15, in which they are addressed in terms of register pairs if you wish to. So you have register pairs 0 through 8, and then you have the accumulator in addition to that. So the accumulator is typically where all the mathematical operations go on to, like your adds and your increments and junk like that. So the instructions, as you can see, are either 1 byte. A lot of these are 1 byte in size. Some of them are 2 bytes. The immediates that you ship into a register, maybe typically 4 bits. You can also do 8 bits if you want to. There's a 12-bit stack pointer. So the whole system can address 12 bits worth of memory or ROM space, which is basically 4,096 words, with each word being 4 bytes, like 16K. That's going to be the entire extent of the system, 16K. So outside of this, the stack is only 3D, which means you can call a subroutine, which calls a subroutine, which calls a subroutine. So once you've gone beyond 3, then it starts to nuke that stack, and you're not going to be able to return where you came from. So you got to be really judicious with your use of subroutines. You got to be, if you need to go deeper than that for some reason, you've got to be really clever about storing where you're coming from so you can jump back there. And there's no real way to edit the stack pointer directly other than by calling something like a jump non-conditional out here. So that's going to be it. The subtraction is 1's complement. How many know 1's complement versus 2's complement? Several people do.
You
Okay.
gotta love 0 and negative 0.
Yep, so that's exactly what this CPU has. There is a 0 and there is a negative 0. And so when you're doing math, especially for a calculator, you have to be wary about simply just adding things to a negative number. So essentially, it's fairly easy to deal with. I just take an addition of this number, and then I add 1 to it, and then make sure that we always have the 2's complement doing. So, like I said, no Booleans, and so you can kind of account for that by maybe loading f, the number f into an accumulator, it's all 1s, and you can say, you can add 1 to it at the time, and then if you add 1 to it, it will overflow. And essentially that can be your Boolean check if you really have to. So there's ways to use the status flags, basically, for emulating a Boolean instruction. And then finally, yeah, lots of instructions relevant to the chipset. So there's not a lot here to work with. So it's interesting thinking in this mindset to write the code, but believe it or not, it's easy to kind of keep everything in your head because it is so simplistic that you can just kind of get in the zone and write the assembly code pretty quickly to make all this stuff happen. So, talk about the development tool chain. What we've got here is on the left, I write the code in Notepad++. There's actually some interesting plugins you might be able to use for this particular chip on VS Code, Visual Studio Code, which is a really great editor. And probably have a much nicer syntax highlighting than this chunk, to be honest. And through VS Code, I could probably do some additional tool chains and save some manual steps up here. But it's fairly easy just to copy the code that I've got in Notepad++ into this assembler that I've got from here. And remember, back a few slides, this was the link e4004.scyc.org has your assembler simulator and precise documentation. So you go to that website, pop in my code into this window, hit generate code, and it spits out the object code, and then it spits out the hex code as well. So basically from there, I can take the object code, pop it into their simulator up here. I can step through it to make sure that things like addition or things like the writing to the display will probably work properly. So I can look at the contents of the registers, look at the contents of the RAM as I step through the instructions and make sure everything's good. And then from there, I can take the hex code. The hex code is in the Intel hex format, which basically there's addresses up here. There's they specify how many numbers are going to be following this and where the address is. And the ROM, and then they have the numbers there, and then there's a checksum bit at the end, and there's some additional instructions like jump to the slot if you want to. So the Intel hex format is an interesting way to encode the contents of a ROM in a concise fashion. It's going to be a bit more compressed than usual. But you can take this and dump this into Notepad, and then you can use a program for the TL866 ROM burner that can pop down my 28664 ROM into the zip insertion socket ROM burner, and then hit go on the programmer, and then it flashes it in a matter of seconds. And so it really is pretty easy to write programs for the 4004 using this particular toolchain. Anybody have any questions at this time? No?
If anybody hasn't seen, too, there's a wonderful video on YouTube that's called the Intel the MCS4 story,
Nice.
which goes through kind of a nice overview of how Intel intended for these chips to actually be used. And it's quite wonderful. It's about 25 minutes.
Nice. Intel MCS4 P.
So you're probably going through multiple iterations with your code, trying things out, assembling it, putting it in the simulator to test it. Is there any way to automate any of that? Like, do you create like a regression suite or anything like that, or it's just eyeballed every single time?
I just eyeball it. I'm sure that I could theoretically put in some little checking code at the end that would say, hey, you know, these registers should equal this, and if it's not, then we flag it as such. Oh, that's actually an interesting question. So, you know, as we write the code in here, I will think about, by the time it goes to the simulator, kind of modifying it just a touch and trying to put in dummy data into the assembler, so that as I step through this, because obviously this assembler has no way to do input from a keyboard or anything like that. Everything's got to come from ROM. So I have to set up in advance, you know, two numbers that I want to add to each other, or something along those lines. I set up the dummy data for what I want the VFD display to show. And so in all that stuff, there are some sets of instructions where, you know, from the actual keypad, it's just using immediates of 4 bits, but then loading from a ROM, I have to use the immediates of 8 bits. So it changes a little bit of the program structure I have to write to account for those sorts of things. And so the code that gets simulated is not necessarily 100% the code that actually goes onto the ROM. So from that aspect of it, I will set up some test ROMs to at least see with the inputs, and then from there I will visually verify the outputs. But I think that's an interesting point to go on automatically, how to verify the outputs and then spit out some status code, or maybe the accumulator value that says, no, this didn't quite work as you expected it to.
There are actually some 4004 cross assemblers that were written in Fortran that Intel did, and I have hell trying to actually find them.
Oh,
It
yeah.
would actually be great to find, trying to find all those old cross assemblers. Because that's how Intel expected, if you were doing mass development of 4004 code or 8008 code, etc., they wanted, you could take and do your assembly and then run it on, you know, an IBM 360 or Control Data 6600 and get your data, you know, get your output back. In Intel hex format, you would take and drop it in the paper tape.
Oh, cool. Oh, my gosh. The old paper tapes.
Yeah.
That's crazy. And yeah, I mean, I can't even imagine all that kind of stuff. Writing in Fortran, going through a big old mainframe and then spinning
I'm
it.
actually trying to put together a series of videos that actually shows how all that actually works.
Dang. Well, if you need to lend you a paper tape machine, I actually have one.
Okay.
So there we go. It's questionable as if it works, and it also is an HPIB interface, not an RS-232, so that might make it a little bit more challenging.
Oh,
It is what it is.
yeah.
So, what's the time check, basically? I didn't bring a watch with
We
me.
got, I think 10, no, you can run a little over, but it's
Okay.
3:55, so.
Okay, cool.
You can run a little over.
So the MCS4 system I.O., as I was kind of alluding to earlier, you have 8 chip select lines. You can specify if they're being used for input or output, and through the board itself, you are given 74 161s to drive the LEDs. The chip select lines are driven by 74 AC138s, which will make it active low, so that means chip select is active low on the board. And in a lot of cases, this actually works. Like a 125 is totally compatible with that. But if you're using a latch like a 373, and you're not necessarily latching the output enable, if you're latching the latch, actually you have to invert that signal. So that makes for a little bit of complexity in the schematic, which you'll see in a second. But ultimately, you can read all this stuff. But the main point is you use the SRC instruction and you give it a value such as 0 through 70, for instance, to address your chip select line. And then from there, you can set an instruction such as WRR or RBR, to either write or read to particular ROM or RAM output device. And this is a strange concept. The 4004 actually supports ROM chips that have the I/O lines on them as well
Yes.
as the RAMs. And so now you have the capability to expand your I/O way more than you might initially think, because all their extra devices are capable of talking on the same bus, taking I/O.
And it was their way of actually trying to simplify all wiring up the ROMs in the first place.
That's very true, because that was one of the major headaches they're going to have. How do we simplify the communication channels for all this? And so
Yes.
having every chip in the entire system capable of talking I/O was really helpful.
Yes.
So here's the calculator design in the hardware. I only have 5 extra chips on this from what was given to me by the MCS4 and what was handled for me by the VFD module I'm using. So ultimately, all the I/O lines are either driving the VFD module, and like I was alluding to, I have to put a little inverter ahead of these so that I can trigger the latch enable rather than the output enable. Because frankly, the VFD module is always going to want the output enable, or else it might get confused and might start jumping signals in weird ways. Also, the keypad should also have its output always enabled, because, well, as you have output set, and then if I were to set input, then this thing would no longer be driven. I couldn't read what the output from the switch matrix would be. So ultimately, the 74573 needs its output enabled driven by the input line so that it can drive the bus at the time it needs to. You don't have a bus collision. And now the keypad is a switch matrix, so basically 16 numbers, 8 lines, 4 columns, 4 rows. I can feed the columns with a high or low value, and I can look for essentially that same value coming off of the columns. And if it exists, then I know that this row actuated this column. And if nothing exists, I can see that this row does not have anything actuated in any column going along with it. So switch matrix is fairly clear to everybody? So switch matrix is actually pretty important in pinball machines in particular, and I do a lot of stuff with pinballs, of course. And so a lot of these you'll see the CPU shipping off a particular active row along 8 lines, and then looking for the active column along 8 of the other output lines in the same way. And so a lot of these pinball machines, you can have 64 different switches for drop targets or stand-up targets or rollovers or pop bumpers or what have you. And so, and of course nowadays they don't go to switch matrix anymore. Everything's on like an I2C bus, which is a lot more efficient. It saves a lot of freaking wiring, to be honest. So, yeah, absolutely. The switch matrix is pretty interesting. Sorry to kind of gloss over that a little bit, but another important thing about all this is the logic levels that you use. Now, the 4004 chip needs something a little bit beefier than your normal TTL, which is your low power Schottky, which is just transistors that kind of talk to you amongst themselves. And so in this case, I have to use the CMOS logic, which is the HC logic family, in order to drive the logic levels higher to provide the correct input levels in the 4004 or to see the input and output. However, the VFD is actually totally fine with LS logic, and so in this case, the schematic I can cheap out and use an LS latch rather than the HC latch. And so these are essentially the voltage levels. As you can see, there's output low, input high, output high for each of these, and you can get the gist for exactly which logic families need what logic levels to manifest a low or a high value on the bus. And so this is important when you're having different devices interface with each other. Otherwise, you're going to wonder why nothing's working.
Well, it's, 4004 is PMOS too, so there's a whole bag of problems that come along with that to begin with.
Oh boy.
Multiple voltage sources.
Yeah, and then, I'm so glad that this MCS4 board was designed, because when I was looking at the specs for the CPU, I'm like, wait a minute, this thing takes +5 and then -10. How do I deal with that? And I was like, okay, if I have this thing without a board, I'm going to break it somehow, because I'm not going to understand what I'm doing.
Nothing does that anymore.
Nothing does that anymore, for sure. Everything's 5 and 0. So I'm sitting here going, okay, thank goodness for this MCS4 that I've got. Otherwise, it'd be completely challenging and just anxiety-inducing time to complete this project. Anyway, this is all I've got for the presentation, and with that, thank you so much. And is there any final questions before I turn it over to Thomas? Yes?
How far away from the ray tracing engine?
The ray tracing engine, I think that's going to be a pretty large ROM.
You can do that with 6 points.
We're going to have to do that. It's going to be about 3 or 4 points.
yeah, 4004 is running at 500 kilohertz clock rate.
Yeah, I was just gonna say maybe 750 if you're lucky. So it's definitely not gonna be fast.
You might get 1 point plotted every 5 days.
So, are you gonna have hardware for us next time?
Next time there will be hardware for it.
Yes!
Nice.
I think it'll be wired up and demonstratable, and you can play with it. And hopefully,
Maybe you can
kind
do
of
it.
invented the corner cases where if you try to break it, it won't actually break.
That's cool. Much respect.
Maybe you could do a little 5-minute lightning next time, just
Yeah.
to show off your
Kind of the follow up onto it.
whatever you
Here's
got. Yeah.
Where I came from. I think next time I'll probably talk about some of the specifics, like gotchas around doing the 4 functions that I want to build for us.
Are you designing more hardware, or is this just on a breadboard, these additional chips that you talked about?
So basically, you got the MCS4 board, which connects to my breadboard via jumper wires.
Yeah.
And then from there, these 5 chips just on a little corner of the breadboard with some of the supporting pull-up resistors and whatnot. In addition to them, the VFD is broken out onto its own little like jumper wires onto itself as well.
But are you gonna lay out a little board for it eventually, or are you gonna?
Probably
solve
not. I
out
think the breadboard is going to be it.
Okay.
Yes.
So what all did your calculator end up being able to do? Like, what were your goals for that?
It does addition, subtraction, multiplication, and division of integers.
Okay. How did you get multiplication and division working without Boolean operations?
So there are interesting ways of doing this that I forget off the top of my head. I think the division is actually done by using remainders rather than decimal points at all. So it's going to show something like, 6 divided by 4 is 1R2. That's going to be ultimately how it goes. And so I think there's some tricks with bit shifting and values that show up in a particular part of the memory after you've gone through and realized that this value is less than this one. You can stop there.
But you are still able to bit shift with this?
Yeah, definitely. Yeah, the bit shifting is actually critical to anything working. Otherwise, I could not get any booleans whatsoever.
Because you definitely, I was thinking, like, if you had to multiply or divide without bit shifting, that would be insanely difficult.
Oh yeah, that would be a lot of.
That'd just be a lot of addition.
A lot of testing for the overflow bit to show up, I guess. Pete, you got another question?
So besides the lack of any Boolean operations, I think I saw one branching instruction, which was an odd one. I've never seen that particular one before.
Mm-hmm.
How do you handle branching? Or are the programs so small that you don't really need to?
There's definitely branching involved, and so there are paging types of concerns to accommodate. I believe it's 256 words per page, or 256 bytes, right?
You'll notice, for example, right there, you have the different jump instructions. One of them is jump unconditional, and that works with traditional jump instruction. The other two are essentially combined together with the different processor register flags to implement branching.
So
Yeah.
they do respond to flags and the jumps.
They can, yeah. So in particular, one interesting one that you have is the Ise instruction, which is increment and skip.
Yep.
And so Ise allows you to increment a register, and then if that status flag goes to 0, well then I believe jump. That's the one that jumps on 0, right?
Yeah.
Yep.
Okay, that makes sense.
But if it's not 0, then it'll continue just running down the line. And so I use this for like loop delay loops, basically. Like if you saw my 4004 Hello World project, it cycles the LED about every second. So it was a matter of tweaking these values on 2 different registers for Ise to be able to go through and make the appropriate delay. This Ise is also up here because I can increment a register, and if the register value in the accumulator matches the value that I've got by basically overflowing, then I can say they want to do an addition, multiplication, subtraction type of instruction. So it's like if it overflows here, you go to division. Add 1, if it overflows here, go to subtraction, stuff like that.
So do you increment with one's complement until you get to -0?
You increment, yeah, essentially. It's just adding 1 to each time. And so, yeah, to kind of go back into the 2's complement, if you have a number that's supposed to be negative, obviously invert it and add 1 to it this way that when you add it to the other number, then you get the value that you expect, and it counts for -0. You don't have any more -0. So this is why, like, when you look at data sheets on things, you'll see that like a 16-bit integer would be -32,768, positive 32,767. You get an extra number on the minus side because of the 2's complement, accounting for only 1 0 rather than 2.
Yes.
you have any additional questions? Anything you want me to elaborate on or that you saw? I believe we're waiting on the pizza. Is it here?
Pizza here, I see.
Sweet.
Here or the other room?
This room's cooler.
I think it's,
Yeah, why don't we put it in here?
We can set it up on one of
Thank
these. We have pizza, so a little intermission, and then Thomas will talk about.
Hey, guys, how you go?
Doing all right. How are you doing?
Pretty good. We may have if anyone, a couple of things. If anyone has a little, wants to introduce themselves, or talk about any project, something like 1 to 5 minutes, really quick.
I was gonna be hanging out here for quite a bit of time, doing like stuff in one of the rooms. Then I was gonna go home and probably work on the machines.
Oh, okay. Very briefly.
Yeah, I mean the kids are. Oh, cool. Yeah, the kids are great. Grandma's and what else is there? I can't even remember where I was going with that. Oh, I have like Stacy's off of the minutes. So
Oh, you're by yourself?
by myself in the house. I'm extremely tired from having so much going on in the past couple of weeks.
Tell me about it. I didn't bring anything with me because I've been working on rebuilding my car. Like a car I just bought.
Nice. Oh my gosh. This tastes like freaking candy.
A little?
Not really.
Get used to it.
What's up?
So,
3 deep on the stack. Oh yeah, it's 12 bits on the stack. Yeah.
So how do you handle? I mean, there's no push and pop.
No, there's no push and pop.
So if you want to get deeper, how do you do that? How do you get things on or off the stack?
You almost have to put it in different registers or shove it off into the RAM as you're doing this.
So you're just ignoring the stack.
Yeah, pretty much. I mean, to be honest, I don't think that you actually can read what the stack pointer even is.
Okay.
And so there's no way to go back and like store that in ROM or RAM. And you would almost have to like have something that as you compile a code, as you assemble it, be able to point to like, hey, this is where this address is. I guess you could do that by means of like a word, right? You could set like an assembler, a compound constant is where a particular address is, and then refer to that address. You'd be like, hey, by the way, I came from here. As you see a word, and then say you want to go back to there. In case I have to go so deep, I can set this in a few of the registers I can put in the RAM as well. But luckily, I'm not having to dive through more than like 1 or 2 subroutines easily. And I have like tried to make some optimizations such that I don't like loop unrolling. I'd rather conserve my RAM rather than do performance. I don't care about performance for later.
Is kind enough to say
And I also
about his
experience deeper than networking thing designing.
Yes, I don't know if you guys got the thing together or not. Across the hallway.
They didn't really do that back then. They weren't thinking
Yeah,
about
the network's pretty set up. I was lucky enough to be able to purchase.
Right? So here's the thing.
Last year.
You have
And it's a really cool
the
RS compared to
paging, obviously.
network setup that was used by
You have the
classrooms.
paging, obviously, where you've got
A lot of classrooms, a lot of states.
Okay.
I basically set up a
like we used to do the edit time with 16K blocks?
Yeah, pretty much. Except now you're dealing with like 256 byte blocks, I think.
Okay.
Oh
yeah, so you page those in and out.
Yeah, so you have to page. Essentially, have to make sure that if you jump to something, like you can only jump to an instruction on the same page. Otherwise, you got a long jump using that jump unconditional to the different page.
Oh, that was back in the 4004.
Yeah. And then the other thing is, if you have
So I've stacked the hard drive with like 20 games.
like one of
And
these
so each of the student
jumps,
stations are running
like a jump interact that's actually straddling 2 pages, then I think it'll finally actually jump to the thing that's on the second page rather than the first page. You have to make sure where your jump indirect instructions are in the ROM for it to behave in the way that you expect it to. There's some pretty wild things you got to consider, like where freaking code lives in ROM.
Oh,
you're actually filming yourself?
Yeah, I am. Live streaming.
Oh, cool.
I like your case.
Oh, thanks.
Put it together and come up with find all the software. It's
Good talking.
Hmm?
very few and far between
my card.
as far as like,
Oh yeah. Oh, look at my phone case.
Who's our audience right now?
But yeah, it's a full
I guess we have 2 people watching. It's not much.
On what?
Look, I'm not going to show your credit card info.
No.
Well, you're showing me the whole thing.
I was putting it side by side.
Oh, I see.
Showing her, see? Cassette deck, cassette deck.
To watch it do its thing, but yeah. just like a little
Read my card all you want, I'll just say it's fraud.
Looks
true.
really, it looks really, really slick. Yeah.
Thanks.
You guys,
Yeah, thanks for bringing it all up. That's, that's a lot of hardware. Like everyone's bringing laptops and things like this.
It's fun loaded.
Wait, who's that live streaming
Keeps
to?
me in shape.
Oh, YouTube.
YouTube, okay.
Oh, here's Nate.
Of course, next time I'll try to have some. I'll try to put some stuff together next time where I can actually present it.
got a
There's
question
really
for you
cool
when you're done
video
streaming.
here at
It'll probably be after Thomas's talk.
It'll be a great talk. Yeah.
I'll try to get a digital version of that set up to where I can actually set
Everyone's, like,
up
moving out of the
60
way.
students and
You're
run
good.
them all in one
You'll be
house.
live streaming a blank wall.
Yeah.
It's really a sweet setup. It's really nice. So
Glad to be able to get
Live
some
stream the
great show
whole
off.
peek and poke and digging down in deep and
I'm live streaming the
wondering if
talks.
it's a porn conversation or you're talking about computers.
Right now, you're just making a lot of pizza.
Well, I mean, everybody's free to get pizza.
I mean, the people you're live streaming
Oh,
to.
yeah, I suppose.
I got a question for you about programming.
Sure.
So I got
Well-
one of those 8086.
To match the model for you because it's still hard. It's the model.
So if I got one of those 8086, you know, like it has an integrated keypad and
Mhm. Oh yeah, one of the big boards.
yeah, would that be a good way to start learning X80 or 8086 assembly? Brian keeps calling it
Probably.
X86 assembly, and I'm
Yeah.
like, I keep telling him I'm not trying to learn modern X86 assembly.
Sure.
I want to learn how to do programs on the 8088 and 8086 and start up from there.
Right. And honestly, I would call that IA32, I guess.
Okay.
The instruction architecture for
It's
30.
not really
Well, no,
I-32.
okay, no, it's not.
I
It's
feel like I-16.
right, but I'm thinking about like x86 instructions date back to like 1974.
Yeah, that's kind of what I was getting at, like early, and then, I mean, I know basic programming, but I know nothing about assembly. Like there's what, AX and DX and different registers.
Yeah, there's AX through DX on the x86, and then you don't really have an accumulator, I don't think. You got a stack pointer and a program counter. It's basically where all the mathematics happen. And you get a richer instruction set.
Do you think it might take me like a few weeks to learn?
Probably. I mean, I did a whole like semester course on it back in college.
Did you take x86 in college?
Yeah.
We were lucky enough to do ARM.
Oh, nice. Well, so when I was doing the CAD stuff, that was implementing an ARM processor.
Yeah.
But then we did, obviously, if you do that, you learn a lot about ARM assembly. And in particular, is RISC, actually. RISC processors. We would design in CAD.
5 or was it before?
Well, I have no idea. I think it was probably from the early to mid 90s.
Okay. Well, RISC-V is much more recent.
Yeah. There's a limited instruction set. I mean, you don't have all year to do this project. It's 10 weeks and a quarter. And then there is the assembly class as well for just how do you program a x86 chip in MASM, basically.
When did you do your graduate degree?
2010, 2011.
You finished just as I was getting started.
Yeah.
I got started in 2012.
There you go.
Well, I just graduated.
Cool.
Did
What do we get? Rosati's. Heck yeah.
This is my friend Amanda.
Hey, Amanda.
She also has a graduate degree.
Cool. What did you study?
Informatics.
Oh, interesting. Informatics? Wow.
I work in electronic health records.
Yeah, the
She's more of
what
a
do they call
gaming
it?
nerd.
I see. The EMR, huh?
EHR.
EHR. Okay, what's the difference between EHR and EMR then?
A medical record is like dental, behavioral health, and then a health record is just like
Okay.
She's the opposite of us. Extreme extrovert, extreme or she's not an extreme introvert.
You're doing fine, I mean.
She thinks she is, and I said, no, you haven't met Brian yet.
Oh, goodness.
Brian, you already know Brian's
Of course.
extreme. Yeah. Like Brian would get nervous around this many people.
I'm already getting tired.
Oh, no. Well, look at some systems. There's plenty of games to be played. You don't have to talk to anybody if you don't want to. Yeah, we'll get Thomas's talk rolling momentarily, I guess, once we're all settled down with the pizza. I mean, the fact that Dave has enough taste to get us Rosati's, I think, speaks volumes as to the quality of these meetups. I mean, it's like Chicago style. It's not quite deep dish, obviously, but...
Yeah, I forgot, you'd know about Chicago style.
Oh, yeah.
You went to school in, was it Champaign-Urbana?
No, it was Northwestern.
That is Chicago, right?
Yeah, it's there's a campus
Yeah,
for
yeah.
law and medicine in Chicago, and then just north of that in Evanston is the rest of it.
I just keep thinking
business and then the
Champaign,
undergrad
because
stuff.
Well, what the hell came out of there? Like, not Pine. Pine came out of Washington State. NCSA Mosaic came out of Champaign-Urbana.
I mean, it's a. There we go. Thomas knows, but yeah, it's a pretty big engineering school for sure down at UIUC.
Come on.
But what's really funny is how often they would how they would do in football versus Northwestern sometimes.
Right. Well, Northwestern had a football team, right?
Well, we do. Yeah, it's Division I in the Big Ten. It's one of like the.
That means.
Okay, so it's like one of the 73 football teams on the Big Ten, and I'm kidding about that because back when I was there literally were 10. And then there's like 16 of them.
So my university didn't have a football team. We had a baseball team.
I see. Oh, we have like the whole gamut for Division I. So Division I's got like all the big sports: football, baseball, lacrosse, you name it.
Isn't lacrosse supposed to be a bloody sport?
No, that's rugby.
Oh, okay. It's kind of a weird get-together. I mean,
Oh, basketball, of course, too. I shouldn't forget.
Besides the fact that it's
big
hot,
deal
there's
in the
more
Midwest.
spectators and people that actually brought things. Like, you know how it is. Usually this room,
It's
not
filled
as
up,
packed
too.
as the other one, but it's pretty full.
Right. Well, Thomas is like he brought his stuff in here, and I guess Michael brought some stuff as well. That's about it for this room. So,
I'll show you something.
yeah, let's have a look. Are you ready to start?
Might as well be.
Okay. Well, then let's set this down, and we can get on with it.
Potentially, one more thing before go. Let me pull something out of my hat here. At least out of the bag. Steve-O. Okay. So on the table here, I have a variety of Fujinet devices. One for the Atari Lynx, one for the Coleco Atom. Here is an Atari Fujinet, of which Michael has one back here on his 800XL workstation as well. And this is the prototype of the Apple II Fujinet, which plugs over the smart boards.
And these are these right here?
Yes, all of those are Fujinet devices that you can either build yourself using the hardware that's available on the GitHub, or you can purchase from Fujinet Online or one of the many vendors. So, I guess with that,
You going to talk about the ports on these, or do you going to address that in the talk?
What is Fujinet? Well, for those who have been living under a rock for the last 2 years, Fujinet is an 8-bit network adapter. And you can think of it as the ideal network adapter for any 8-bit computer or console. It's based on the Espressif ESP32 microcontroller with a good deal of firmware that does its best to provide virtual disk services so that you can read and write software either over the network or via local source device. It provides virtual printer with over a dozen different printer emulations, rendering out to a PDF file that you can pick up on the internal web server that's on these things. It also provides a virtual network device. This network device has a whole bunch of protocol adapters for all sorts of different protocols. Everything that you can imagine, from TCP, UDP, but also stuff like HTTP, HTTPS, FTP, FTPS, SSH, SCP, SFTP, you name it. All on the firmware. And with the firmware doing its darndest to provide a nice clean input and output channel to the target machine that it can use at its leisure. In addition to that, it also provides built-in JSON and XML parsers so that you can feed it a JSON document from any endpoint, HTTP, HTTPS, whatever, have it process it, build it into a document tree that you can query for the specific pieces of information that you need. Again, at the computer's leisure. The consequence of this is that Fujinet is the only 8-bit network adapter out there right now that can not only talk to services with crypto, but modern web endpoints and APIs natively, without needing to take and put a server in the middle to do any translation. That's the Fujinet advantage in a nutshell. And on the table where you saw all these different devices, all of these are merely just different bus connections for essentially the same device that's on here. And it's all running the same code. So as more of these systems come online, and as more people from these various communities take and contribute software and contribute to the firmware, it benefits all of the community all at once. So what's this thing like to use? Well, I'll see if I can do a demonstration over here on the station over here. Hopefully this will work. We have an Atari 8-bit here running Fujinet. And I will take an aside to say that we've even ported Fujinet to run on standard PCs so that the potential as emulators get external device support, we can take and hook into those as well. An example here, we have the Altera emulator, which is an Atari 8-bit emulator that has external device support. And we were able to hook into it and provide all of the Fujinet functionality. When you first boot a Fujinet system, you see the screen divided into two sections. It loads a program called config, which sees if it needs to set up the network configuration, pull everything together. But it also gives you a set of hosts up top that you can pull disk images from, and a set of drive slots down below, which correspond to individual disk drives, in which you can mount those images in. This is the most basic way that you can operate Fujinet in the first place. So to demonstrate, we'll go to a TNFS server here, press enter, and we see we have a lot of different pieces of software that we can choose from. We can load existing games, existing software, no problem. So, I mean, just at its simplest, we could do something like, let me just find something real quick, something simple. Yeah, just something, anything at all, doesn't matter. We mount it, we go ahead and we press option, and it is booting that software now directly off of the cloud. This is not being run on the local storage, it's literally running directly off of the cloud, directly into the game or the existing application that you want to use. And the computer is none the wiser. It thinks it's talking to a disk drive. So, other things that you can do, for example, I won't go into the virtual printer too much here, but basically you can take things like Print Shop, you can use Print Shop, print out to a PDF file, print onto your normal laser printer or whatever you want to use. And it looks great. I wish I would keep some samples with it. So I will remember to do that later. But for now, let me make sure. Hold on. This is an interesting challenge to try and do this. Oh, I'm still mounted. It's still gonna, this is still mounted, so it's gonna try to reload that again. I'm going to do a cold reset of everything, which should bring us back into the Fujinet menu here. In addition, we have a whole bunch of different network applications that we put together as examples. All of the source code is actually available on GitHub, so you can see how all of these work. Things like the Iss Tracker, for example. Now you'll see with the Iss Tracker actually queries a web endpoint to grab a JSON document containing the latitude and the longitude of the ISS, as well as any other additional data, and then displaying the result on the map, updating every 5 minutes or so. Doing this dynamically. The Atari can do this at its leisure, and the amount of code that you need to do this is less than 1,000 lines. So, let's see, what else can we do here? I'm going to show the other extreme here. How easy is it to take and program something for the Fujinet? And for this, we're going to take and go to Atari apps here, go back into networking, and we'll see there's a Mastodon client right there. Do I have basic in? No, but I need here. Whoop. Okay. We'll go ahead and note that in, just like anything else. And we will boot. Now this particular disk has a device driver for what's called the N device on the Atari. And it provides a fully integrated device to talk to the network adapter. And that's kind of the guiding principle for every single one of these targets. We try to take and make it so that we integrate into the operating system and into existing I/O operations as much as we possibly can. And I did this here just so I could actually load it so I could show you the entirety of what it takes to log on to Mastodon and to get the latest post. We can see right here, first we take and set up a variable for temporary storage. Then we use the open command to open up an endpoint for a Mastodon endpoint, old bytes.space, using its API calls directly. We're using its JSON API calls directly. We're asking for a public post, and we want the most recent post. At which point, we immediately take and change the channel mode from protocol mode into JSON, so that we have access to the JSON parser. After which point, we can start sending commands such as P to parse the resulting JSON document, and then we query using Q to query for the particular bits of information that we want using a JSON query path. At which point, we can use the traditional input and output commands, input, get, print, put, whatever, to do I/O, to get the data back and on to the next thing, and so on. Finally, when we're done, we take and display all that information, and when we're done, we close the connection, which closes the protocol, closes the socket, does all the housekeeping for us, and the program ends. Then we have a Mastodon post. What? Roughly 20 lines of code? How many lines of code is that? 10? Yeah. So that gives you an idea of the possibilities of what you can do with very little code. I literally designed this so that one of the use cases was the 10-liner basic contest, so that people could take and make network games or whatever just to be able to fit into 10 lines, just to see if we could do something useful. Because, you know, we can make full-blown games in 10 lines. Why not add some networking functionality in there while we're at it? Now, as far as documentation and the like, there's tons of it. We have if you go, pardon me here. Oh, no, you did not. No, I didn't say that one. I said this one. Do this one. Yes, up here, please. We can go to Fujinet.online. And it's a good jumping off place. Yes, this says Fujinet 8-bit compatible network adapter, and you see the one for the Atari 8-bit which comes in the back here. But you have different jumping off points for things like the shop, the support, and the wiki, which is where we're trying to put together all the documentation. Speaking of which, if anybody is a technical writer and has a good grasp of writing technical documentation or aggregating it, we could really use the help to try and get everything that's in my head out onto the printed page, so to speak. So we have all the documentation, which it starts off with the quick start guides for the various platforms that we're bringing up. Oh yeah, by the way, on some platforms that have audio pins, we embedded SAM into the firmware, so there's a speech synthesizer sitting in there. On the Atari, it's exposed via the printer port, so you just print to it. So you have different things for using the end device, how to do all of these different things, just different, all the bits and pieces that we take and gather in, as well as all the available commands that you can use inside the Fujinet itself. So really, all of this, and I'll just cap this off by saying that all of this is in a device manufactured by multiple vendors. We went out of our way to make sure that multiple vendors could take and provide for each of their respective communities for an average price of about $80. I used to say 60, but you know, chip shortage. But yes, the only peripheral you will ever need. So that's really the end of what I have here. The only other thing is if you stop over at my table over here, you'll see there's an Apple IIc that is running the latest one for the Apple II. It plugs in via the Smart Port. Now, if you think about it and what the Smart Port actually is, Smart Port is an extended version of the Apple Disk 2 connector. So we're using Woz's floppy disk controller design to implement a network adapter. And when I discussed this with Woz back in January, when we had the first working prototypes, his response was, and I quote, "fucking insane." So, the goal here is really very simple. Like I said, we want to try and get this onto every single 8-bit computer and game console by the end of the decade. Full stop, no exceptions. And anybody who can help make that happen, come to our Discord, and there's a link to it in the Fujinet.online. Come to our Discord and help us make this a reality. Yes?
Yeah, I have a question. What does it look like to port this to a new machine? Let's say like this AIM-65.
Yes.
It has no built-in concept of a disk or
Okay,
a
and
file.
good thing you got me here with the development environment, because I can actually show you what's involved here. If it will, yep. That's a darn good question, and I will try to answer that as best as I can. We have right here a little VS Code window that contains the Fujinet source tree. Now, the text here is absolutely gargantuan, but we can kind of see, no, absolutely not. We've split up the code into separate concerns for different bus types, such as for the Coleco Atom, the AtomNet, ComLinks, IEC, for the Commodore 64, and IWM for the Apple II Smart Port. And we have and for each one of these, you'll see a new type here, which has a template that you can start off with to actually take and implement the different bus methods. In addition, you also have in addition to the bus, you have device. And each of these implement the individual devices that are going to be available on those target machines, the disk drives, the Fujinet control device. And in this case, the AtomNet has the keyboard that plugs into that same bus. So we implemented a virtual keyboard, modem, network, etc. and those implement the primitives for each of the devices. For the Lynx, we have the virtual disk and the control devices, and so on.
So in his case,
yes,
there's a C1541 emulator card that he has in there.
yes.
So
that can use the the existing stuff that we're using for the IEC bus. In that case, it'll plug right in.
And then it would just
that
be
has its own issues. It would almost be better to have something that just had a serial interface, or
Yes.
something generic that would get like all that the long tail of 8-bit devices in one swoop.
That's the thing. We are trying to do the best type of integration that we can for each individual hardware type. And because we've sufficiently modularized the different bits and pieces of the code base, we can actually concentrate on trying to make the best possible integration for each individual machine type, rather than having to go for a lowest common denominator. So, I mean, if we wanted to, I know that AM65 has a bus connector on it.
yeah, the address lines are
Like address and data line. Basically, it has memory
Yes.
mapped IO.
Yes. So we can either go through the serial port, or we can go through the bus. And all of that here, all you really have to do is take the individual bits and pieces that we had in the library here that comprise these devices, use one of the existing templates for the bus to take and implement the bus methods, and then you can basically move over into the devices that you want to be able to emulate. And all of the firmware is actually being written in C++, and there's a ton of example code inside of it. And I've also done a workshop that's on YouTube that goes through and walks through the whole firmware tree and how every single thing works. So all of this is doable, and doable in a very nice fashion. I will, for anybody who wants to take and work on this and hack on this, I have a saying that I say over and over again. I have very limited engineering time, very limited engineering cycles, but I make unlimited I make unlimited time to teach. No exceptions. So anybody who wants to take and help work on this, I will bend over backwards for you.
Thank you so much for that presentation. That looks like a fantastic system. So.
Thank you.
It's really pretty amazing.
So, yeah, like I said, the latest ones are over here. I didn't have time to boot up the Lynx real quick, but one of the show pieces for the Lynx is literally the Iss Tracker running on the Lynx. Yeah.
Could you say which platforms are supported?
Right now, we started off on the Atari. We did the build for the Coleco Atom. Then we moved over to the Atari Lynx, got it working. Most recently, we've got the Apple II up and running here. And we have one guy who's leading a small team of people to take and work on the Commodore 64 IDC version. And we have other people such as Owen Reynolds, who is leading up the integration for the ZX Spectrum, for example. And different people. If you look at our Discord channel, we have tons of channels for bring-ups. The whole point is to get people together. What I've built with Fujinet, since I'm not asking for any licensing or any compensation for any of this, or none of us are, what we've done instead is we've built a tree fort. We built a tree fort that we all can go into, that we can hack on stuff together, have a good time taking and working on this, and build something that we all want to use. And hopefully something that's a joy multiplier for everyone involved and everyone who uses it.
It really looks amazing, and it looks like it really captures the spirit. You can use this with any machine, and it feels like you're using that machine.
Yes.
It doesn't feel like a weird add-on,
Yes.
and you've entered another world.
We tried to make it integrate in with the existing I/O as much as we possibly could, which we can because we're using this, big old microcontroller on the end here, doing all the heavy lifting and trying to present a nice, clean I/O channel on the other side of it.
That's really amazing.
I'll say, from my experience, every time I come out learning so much about either the hardware, the just might just play games with instead. But now I learned something new. I've learned 6502 assembly through this project, and
that's another thing too. Michael over here took one of the bits and pieces of proof of concepts that I started with on the Atari. The Atari has a modular device system in the ROM that allows you to take and inject additional devices as device drivers for all sorts of things. This is done for disk operating systems. It provides the D device, which provides the file system and all the mechanisms for dealing with that. Now, normally, all of that is running on the Atari, and it takes up a chunk of your memory just to implement one file system to handle a set of disk drives or whatever. But I asked the basic question, if all of the heavy lifting is handled on the Fujinet itself, how much simpler could that make a device that accesses it to do all of the things that you traditionally would do with a disk operating system, but instead do it over the network? And that's where the Fujinet NOS came from. Michael has taken that, he's pushed it forward, implemented the majority of the functionality, just got the binary loader and a few other bits and pieces actually working. So it's an operating system that you can load in off the network. And because everything happens on the Fujinet, it takes up very little RAM space. You have a lot more RAM to work with.
Yeah, about 3K, I would think.
Yes. Yes.
I mean, it's tempting to start. Oh, what can I shove in there? A memory dumper? Yeah.
Yes. Yeah. Lots of potential things here, but because all of the heavy lifting is done on the Fujinet, now if the Fujinet has support for a file system or a network file system or whatever, the NOS has access to it too. You don't have to add support for it. You want to take and one of my old demos was literally using the NOS to load a web page off of a web server into Atari Writer, edit it in Atari Writer, and save it back out with no intermediate steps in between. This is an example.
So another question for you. Are you planning on keeping up with the modern 8-bit systems like the Chicken Lip 64 and other things that the YouTubers are doing? All right.
Yes. Anybody who wants to take and help do bring-ups for their favorite machine, come on in. My job here is primarily I'm kind of the voice. I've been pushed into having to be the spokesperson for this project, but I'm also the facilitator. What do you need from me to get what you want out of this thing? What do you need? I can try to provide it.
Thank you very much.
You.
That's amazing.
Yay.
Did they actually change the name of the commander? I thought it was a joke.
Did they?
I thought that was like an April Fool's with the chicken lips.
No, I think they really had to. I thought there was some kind of licensing agreement or something.
I thought that was an April Fool.
Yeah,
I'll have to look. I thought they had to stick with it.
Yeah,
Because ever since in the 8-bit guys just called it the Commander X16.
I see.
there's the bare hole.
So this is a real live AIM 65, huh?
This is the AIM 65.
That, you don't see those every day.
No kidding.
This one has this little.
That's the one to have.
Running Fujinet.
I
one
agree.
day.
I think that they used to do Gottlieb pinball machines. Used to write their code for their pinball games on one of these systems, I think.
These, the first time I saw one,
can
it was
definitely see that. Absolutely. Of all the single board 6502 machines, that's the one to have.
It is pretty well. The Superboard 2 is not bad either. That's pretty cool too. But yeah, this is pretty great. And this one, I have a little video board. It didn't originally come. It was part of the system for the AIM 65. There's a whole development system, and it comes with a video board. And there's a fellow in New Zealand who decided to clone this video board. I took this to an X-ray machine, X-rayed it.
Oh, nice.
And took him some high-res pictures, and he was able to reproduce all the circuitry.
Jeez, you're lucky you got access to the X-ray machines.
And then he made this little interface board for it too. it's a clone of the original as well. And I tried it out and it works great.
Nice.
And actually, you can get video on it. Even though it's a little clunky. You know?
20 character line text like this.
It's
like this.
I think it's an 80 character line.
Nice.
It's a 64 or 80 character line.
Does it have to be on a terminal or on a TV or what?
It's on a composite monitor.
Okay, yeah.
One of these guys.
Oh, BNC cable. All right, nice.
But
It's a little fancier than your normal.
You can use an adapter and use a regular RCA. And I was going to bring it, but I kind of threw it all in the car.
Oh, yeah.
I forgot the monitor.
Oh, yeah.
The power supply that's required.
Well, next time around, you'll have to show it off.
I'll bring it next time.
And the original setup had on there's the I/O ports over here. You could have two cassette decks connected to it. So if you're going to assemble some assembly language, you would have the source code on one tape, and then it would assemble it, and then write the object code to the other tape. So
that makes sense.
One could only do read, and one could only do write, where you could have one cassette drive doing both.
Makes it a lot faster then.
And this is some guy in Germany made. Back in the day, somebody figured out how to interface the AIM-65 to the Commodore drives.
Interesting. Oh, that's wild.
The 15, what are they?
Yeah, 41s, 71s.
Yeah, 1541s. Because back then, that was a cheap controller, and you just need a serial interface or a parallel. I guess whatever it was. It was a simple interface. And so some guy figured out how to wire that up to the parallel port of the AIM-65 and made a little business out of it. And there's a guy on eBay who sells these little chips you can plug in that do that. Some guy in Germany basically made a little board that will plug into the I/O port in the back, and it includes that little interface. Plus, he put a whole what do they call it? IEC to SMC or whatever they call it. I don't know. IEC to SD. He makes a little, basically, he built a whole emulator for the Commodore 64 drive here.
Yeah.
So you can plug a little SD.
Sure enough.
SD card, yeah. And plus it has expansion for another Commodore drive as well.
Sweet.
So with the whole thing running, you can have a Commodore and a couple of a disk drive, video. Now for all of that stuff, they do have some facility in redirect I/O.
Yeah.
You have to type in some commands. You have to go set some registers in ROM and it set up. And
makes sense.
But apparently there's some odd interactions between these two boards, so it's not.
I would imagine so. I mean, it looks like you kind of put this one in or that one, regardless.
Well, they're different. They go on different ports.
Oh, okay. Oh, there's two ports back here.
Yeah, one's address and data line, and one's I/O, and so one that's like. You can connect this to a teletype, right? So one of the line.
So one's more like a ROM expansion. The other one's your interfaces to whatever.
This is the I/O. It's the real bus. This is an I/O port. But there is some programmatic, like they may use some registers or some order of initialization.
Oh yeah.
Gets in the way. And so there's a whole thread on the VCF forums. There's a very talented engineer in New Zealand who designed, basically reproduced this entire board.
Oh goodness.
And
there's no magic chips on it.
No, it's just a standard old. What is it? What's that chip? 6845, I think. I can't without my glasses. I can't see it.
Is that a CRT?
Yeah, CRT controller.
Yeah, 6545.
Okay, 6545 is just like the 6845. And then there's a guy in Germany who actually is making a similar expansion to this that plugs in to the original expansion, and then you can plug these into the expansion chassis. He made a backplane for the chassis. It's the same guy who did this, so you can plug in. They also made a real floppy controller based on a 1770 something.
Oh my gosh.
And so you can have a whole development system in 65.
Yeah, I agree.
But yeah, not demonstratable today, but maybe next time I'll bring it.
Well, that'll be fun. Okay, let's see it.
So this is an operating system I've been helping with. So it has commands to make directory, delete directory, and these are in RAM here. So I have three devices mapped right now through this. So two of them are pointing to this directory. So So N1 is this directory. If I do a listing
either 15 or 23 or whatever those.
You'll see these files over here.
Senior level undergraduate courses.
If I make a directory here, ignore the error code, but
Okay.
it makes it over here.
Sure enough, there's test 1.
Yeah. So one of the drives is mapped to an FTP server that has some demos. So
Nice.
I'm going to look for not just executables, but a program that is in archive, .arch format. So I'll do a directory of N2, everything that ends in arch.
So like, say you want to get like back down yours,
So I've been playing with this one called Equation.
Uh-huh.
So I made a directory called Equation over here. I'll change the mapping for N1 to go to that relative directory.
This whole term, we're kind of like, okay,
Now
all this playing, blah blah blah. Now
we're pointing to that Equation directory.
Or no, we're install Windows.
In that directory that we were looking at a moment ago, I have an ARC program, so I'll load that into memory. So again, we're going to look for this equation.
Careful.
Thank you.
Really, we're not even going to like install like PHP or MySQL or connect to a database. That was like do something cool.
So here's activity.
It wasn't even a good introduction. It's like
Loads the program into memory.
Boom.
From there, from the laptop's hard drive into memory. So I'm gonna unarc. So I'm gonna use D drive instead of N drive. That equation.
You say a patch. Are you talking about like a software patch, like a service patch?
.arc will be the input file. It's looking for it, and then the output file directory is going to be the equation directory. Let me delete this.
The whole time, I didn't even say Apache. And you started saying Apache.
As long as I can
Then
Oh, I can understand.
start reading it.
Signal came out as singular, the wireless company.
It's
uncrunching, and there it pops up.
It's over here, growing.
Yep.
Alright, so
Boom.
it's done. I can get back to DOS. So I'm here. If I do a directory, I see equation. So I will attempt to load it into memory. I don't know that it's loading exactly correctly in memory.
But it seems to go good enough for what you're putting into it, right?
I think there's supposed to be a little splash screen with the authors, and I've seen gibberish.
Yep.
And then it loads the modified character set to show the names.
I see.
It's not ready. Okay.
Did it, oh man, didn't quite compress right, maybe, huh?
Oh no, I've seen this before, so I still have NWD. Well, now it's going crazy now.
No.
So I do have a cold boot command. So I'll have the power cycle. Let's see if it still remembers. Anyway, that's enough. It would have shown a demo if it was correctly.
Well, it's pretty cool though. You download something off the FTP, you unzip it, you're using storage space off another machine through the network, then you're coming back and running it on the Atari.
Anyway,
that's pretty great. Thanks for showing that. Something that Someday when I get more time, I'd like to play with, because I think that the idea of getting these devices on the network to download other programs is really helpful, rather than having to collect all this old media.
It's fun. It's fun. It gives you something to do.
Yeah, for sure.
So you've got the infrastructure issue.
Let's see what else we got.
Managers want to like they want to see people doing
Thomas, you got your links?
It's like a shift register, basically.
right.
Yeah, that's right. Yeah.
Right. And some
That's
managers
like on any computer, it's not much harder than just a simple parallel. You just have a parallel port.
And we already have the beginning of SDI.
Then you need a card. Then you need a card. That's it. You need a parallel IO.
And for those that won't, we can take and hook it in. If all they have is a serial port, we use serial port. If all they have is a parallel port, we use a parallel port.
All that is on the other end is a
I should switch to the gimbal. That's okay. This is the other room. Got a collection of TRS-80 machines. The Vectrex compact portable. The Next, I think. Oh, and a bunch of calculators too, huh? Here it is. Next station.
A bunch of ancient HP calculators, including a modern replica of the 16C.
Oh, interesting. There's quite a retro look to it.
Love that the book for the first HP calculator is that thick. And then 4 years later, the manual is merely this thick.
Oh my gosh, yeah. Like all that reverse Polish notation in there too. Huh?
70s bearded dude.
Oh my gosh. Yep. He looks happy to be solving this big, huge square root, huh?
Yeah, this is a full computer. It's got a magnetic card reader.
Oh wow.
And a slot to stick the card in to augment what the 5 function keys do.
This came from ST.
And this little guy, sometimes they actually can do calculations in hex, decimal,
Oh, interesting.
binary. It's got all the logic operators. You can even do IEEE 754 floating point calculations.
That must have been brand new back then.
This is a modern version, so it has something that the original didn't.
Oh yeah.
A USB port.
No kidding.
So you can flash the ROM, add other stuff. So it's got the same HP feel. The buttons are still just as stiff as ever.
Yeah. That's good they found the switches with the same feel.
The next to talk to a non-next monitor is a bit of a chore, though.
Oh yeah. Got all these adapters to different format adapters. Looks like a 13W3.
That's correct. This takes us down to VGA. This is a little widget that inserts, I think, sync on green.
Okay.
And then off to the
LCD panel.
Which weighs 4 or 5 times what a modern LCD panel weighs.
Oh yeah, it's pretty beefy, huh?
I guess it must have vacuum tubes in the back lighting it up or something.
Yeah, it could be some really big fluorescence or something.
Or maybe just Jacob's ladders. They're going really fast.
That would be really funny.
I had an idea for a video game once, which would have Jacob's ladder going. If you mess with the controls, they go faster and faster. Eventually, it would become a raster display.
Oh wow! I think the FCC might get mad at you though if it's too big.
Well, you know, if Tesla built this power tower, we'd all be dead of cancer by now. So.
That's right.
Now, the funny thing is, this right here is probably the most hard to find, valuable piece of this whole ensemble.
The speaker.
The sound boxes are usually what people would break first.
Oh wow!
And they often got tossed. And so, I could probably sell this for $500 if I wanted to. I could probably get less than that for the rest of it.
Really?
Yeah, it's funny because at the time it was pretty slick, but look at the mouse. Yep. Rubber ball. Mechanical.
Sticky after a while, and you gotta clean it.
Oh yeah, you gotta get good at scratching the crap off of it.
Yep.
the next book was one of these. They hired, or I don't know how they got him to do it, but Bruce Webster wrote for Byte magazine, I think.
Okay.
And he was tasked with coming up with this Kiss and Tell book about the next.
Nice.
It's just kind of a very big sales brochure.
Tells you about all the features and capabilities and.
Yeah, it talks about each of the main applications that came with it. This machine shipped with an enormous amount of software.
Nice.
Of course, Apple still does that. Except they don't have the complete works of Shakespeare anymore.
Not quite, but I mean, there is a nice video editor. And
you know, Steve thought in 1985, he thought that was important. And so it came to be.
Nice.
No, we owe the Next a lot. It taught Jobs how to behave himself. Gave us Mac OS 10s. And also taught us that you can sort of make a business selling a computer at 4 or 5 times what it costs to build. Or maybe 40 or 50 times.
Wow.
This machine sold for $5,000 in 1992. And even though it says it's color, it's only, I want to say, 12-bit color.
Yeah. I don't really utilize the colors a whole lot on here.
When we first saw it, we were blown away.
Yeah.
Oh my God.
Pretty low saturation on the
It's like Dorothy opened the door on our GUI.
Yep.
And in fact, during the next World Expo, it was the second or third one, when they introduced the Intel board that went into the cubes, they showed that scene where Dorothy opens the door.
Oh, yeah.
Which we now know was actually shot in color. They just painted her, put her in a dress that was sepia.
Yep.
Painted the set sepia so it looked that way. And if you watch carefully, they cut from her opening the door to her stepping out of the door, and they put her in the colored dress. But even so, we were all like, not quite the 1984 ad, but close.
Close. I mean, to see color anyway, it's like Amiga wasn't quite out yet, I guess, and so you had maybe CJ, and that's about it.
No, that's not true. Amigas came out in 85.
Right.
Next really didn't ship until 89.
Oh, I see. So you had some colors there.
Well, the Amiga was, you know, in many ways, Amiga is what DOS should have been.
Right.
You know, IBM, if they had just waited a little longer and not gone to Microsoft for their operating system, which of course we all know they stole from Gary Kildall. I'm sorry, what's his face stole from Gary Kildall. Sold to Microsoft. We might have had something called, what's that thing, multitasking, that somehow the Amiga was able to do, the same chip that Microsoft and Apple couldn't. 68,000.
Yeah, some feature on the 68,000.
There's nothing special about the 68,000. It's just Commodore Amiga multitask. And that was incredible.
Yeah.
Of course, Microsoft had been selling something called Xenix for a long time for that. The 8086 machine.
Yep.
You know, they didn't even need a 286 to do Xenix. I could be wrong about that, actually, now I think about it. But still.
I think I've been reading about that recently, though, that there was supposedly some Xenix flavor.
Yeah. Microsoft, they had a team of Xenix people. In fact, Xenix is where Microsoft got the idea for command.com, for environment variables, and sys devices. In other words, soft loadable drivers.
Yeah.
They lifted all that from the Xenix. And the thing is amazing is that means that CBM doesn't have command.com necessarily. Doesn't have, well, I should say recursively callable command.com.
Right.
And didn't have environment variables and didn't have loadable device drivers. CBM, you had to, I guess, everything had to be linked together in one lump. And that's what got executed. Even if the system was broken in the BIOS. But anyway, the point of all that is, when Apple was selling a Mac that really didn't multitask, this thing came along. It's essentially mock Unix.
Yep.
It's a true multitasking machine. It has true VM hardware. It's also got that I/O chip that has 9 highly programmable DMA channels. Give it the ability to write to the laser printer, write to the Ethernet port, write to the SCSI drive, write to the video board, write to the system memory, all without using the CPU.
Nice.
That's why Jobs called this a mainframe. they had this great poster. They said in the 1990s there'll be 10 great innovations. Here are 7 of them. And they went through a list of things that were only on the NEC. CD quality, audio playback, and with 16-bit stereo.
Right.
Email with attachments, drag and drop.
No,
They had the
no.
first mind-like email. The postscript display was a huge thing.
Right.
More or less got what you saw on the screen.
Exactly. Yeah, renders just what you print on the screen.
Just higher resolution, which was amazing. If you were doing desktop publishing, the Next was vastly better machine.
Nice.
I had frame
On the Mac, yeah.
Then on the Mac, I had Frame Maker on this thing, and I could do anything I wanted. It was incredible.
Yeah, I mean, the desktop publishing seems like it was such a challenge back in those days.
Yeah, I mean,
people wanted to do it, but you saw a lot of results just looked crappy.
The real problem was it was just really hard to go from the low-res world of Windows and early Mac to the high-resolution vinyl space that printing does.
Yeah.
Those fonts, beautiful fonts, are all splines. My first job, I wrote a program that converted splines to circles and straight lines for a film recorder that shot at 2K resolution. At that scale, the circular arcs didn't look so bad because you had enough pixels still in the arc. But on these low-res screens, until the NEC came along, it was hard to do anything that looked like what it was going to print. And getting the kerning right and the spacing, knowing that when you print it, it's not going to accidentally move this word at the beginning of the next line and throw the whole document off.
No. That would really happen? Like you would actually have words shifted around from line to line before printing?
I recall having that problem with Microsoft Word a lot.
Oh no.
Driving an HP LaserJet with one of the built-in fonts. Their kerning tables weren't always correct. Even though the laser printer would kern a little differently. And it was just taking raw text.
Oh, that would be maddening. You'd print the whole thing and it would be all wrong.
Yeah, you had to learn how to insert half spaces and stuff like that.
Yeah, shrink the font and then do a space there or something like that.
Madness.
What a mess.
But we live in this world where everything comes to you instantaneously in your pocket. Computers, it's the resolution of your eyesight.
Right. Yeah, the retina displays and everything.
You can almost draw a straight line of this back to that. This begat that. But it took 30 years.
Of course.
This is what 30 years gets you, though. A little tiny machine runs on a battery all day.
A lot of innovations in the meantime. It's so great.
It's a camera, and it's a video camera, and it's a compass, and it's a map. And it's,
Yeah, the map's super helpful.
Ted Nelson invented the idea of hypertext back in the 60s. He called it, they called the program that was going to do it Xanadu. And he was furious when Tim Berners-Lee rolled out HTML 1.0.
Yeah.
Because HTML 1.0 was a garbagey hack. You had formatting information inside the tags. No. How it's displayed and what's displayed are two different ideas. Which is where we're at now.
No doubt.
Tagging in HTML is textual. And the CSS file says how to draw it.
Right.
Use this font, this point.
Yeah, you might get the notion of a class inside your HTML, but
the funny thing is,
now you don't have to do it like that anymore.
When I was using FrameMaker on the Next, that's how it worked.
Oh, interesting.
Style sheets were CSS files, essentially. So I could say, this is a paragraph, and it's style foo. And that's told which font, which point size, and so on. Margins and spacing, gapping, everything that you would want to care about in terms of how it's presented, but none of the content.
Right.
And that meant that a program could easily say, just give me the content of paragraphs. And in fact, I wrote a lot of Perl scripts that would do that very thing. FrameMaker loved Perl. You could write Perl code that would parse your document. Your printable, human-readable document.
Well, it was the practical extraction reporting language, right?
Yeah.
So, yeah, I mean, you get the text all day long, for sure. It makes it easy to slice and dice things.
And that was another, I can't give Next credit for FrameMaker. It's one of the early innovations.
Yeah.
One thing Next did that was weird was they licensed Mathematica for research. Everybody who got a Next got Mathematica. That was several $1,000 program. Took a little bit of the bite off of the $10,000 price tag
Yeah.
if you needed Mathematica.
Yeah, no, I always.
No kidding.
Mathematica, by the way, is a program that can do symbolic calculus like that. Type in any calculus problem you've ever had.
Yep.
Pops up an answer right up.
Yeah, between MATLAB, Mathematica, and Maple, you should be able to solve just about any of that stuff. Of course, our professors is always like, never try to integrate over 0 or something along those lines. And yet, these programs can do it.
Yeah, they will. They just skip over the whole in this function. Mathematica is it actually kind of understands math symbolically.
Right.
Which is incredible.
I'm gonna go see what's up over on this side before I run out of battery. Definitely. Thanks for chatting. Cheers. Rob, you turned off the mindset?
Still live streaming, Steve-O?
Yeah, still
I can
streaming.
turn it on. Yeah, the power switch is behind the keyboard there.
Ah. Is it on the keyboard or just
On the back side of the keyboard.
Okay,
Yeah, it's
cool.
on the keyboard itself.
I forgot about that. It's like
Yeah,
right
so
here.
click the switch there.
The very rare 80186 computer from Reset. Walked by it many, many times. Luckily, Rob got it.
Yeah, it has a, since you're recording, it has a 8186 processor.
Yep.
I believe it comes with 256 kilobytes of RAM, doesn't it? Or no, I think it's like 64, but I think you can expand it up to 512. MS-DOS compatible, but it's not IBM compatible.
Right.
A lot of IBM specific software will not work. I speak because I used to own one in the 90s.
Yep. Yeah, I mean, the 80186 was definitely not compatible with the IBM BIOS, and so a lot of these programs that use
not
hardware
just-
calls would get
Not
messed
just
up.
that, but if you zoom in, or kind of like if you zoom in, they have, it's locked, but they have cartridges here where you could put games that would be in ROM that would load up faster, but I don't know of any cartridges that actually existed.
Oh, yeah.
So you have your dual 5 1/4 inch half-height drives that are here. The memory's integrated with here. It kind of loads up, what you would call it, PC Junior style.
Yep.
The graphics in here are special because you see it has more colors than CGA. I don't remember what the palette is, but
512 total, 16 simultaneous.
And yet
Okay.
you got the CGA monitor driving this, huh?
yeah, you can still use a CGA monitor with the mindset, but it's not CGA. Like CGA games will work, but
Yeah.
Rob could tell me more, but I think there were a few games that might have some artifacts or not being.
There were very few games that I've tested on this, PC games, that actually worked.
That's what I'm saying. Like I thought there was a few that they work, but they don't work properly because it's not implemented like I guess exact for lack of.
I was able to run an early beta build of Planet X3 on this.
Oh, interesting.
They made some changes later that broke the compatibility. So, yeah.
So it's using a floppy disk, and this is the typical game you got for it. I guess it's like the flying game, right?
This is the game.
This is the game.
only retail game.
It was supposed to be revolutionary when it came out, but I mean, it just didn't really catch on. Like my ex-stepdad that bought this was an electrical engineer, kind of like half the people in this room, so that appealed to him, and he bought one new.
So it's kind of
right.
The game isn't particularly good, but you can't really emulate it. I think it's in MAME, but it's not emulated properly. So the only way to play it is to find somebody with a working mindset, and then in order to play it on the mindset, you got to have the joystick.
Oh, jeez.
So
Which I didn't have.
The keyboard, you can't play it with the keyboard. So if you can find somebody with a mindset and a joystick for the mindset,
oh my gosh,
then you can play this horrible game.
What about the CPU die? I guess
that was just in the free pile.
Oh, interesting.
That's cool.
Oh. What's underneath of it?
Some EEPROMs.
EEPROMs
from Unisys.
Okay.
Somebody brought in. Their father was a Unisys hardware engineer and brought in some parts.
Is this system related to a Fortune? Have you ever heard of Fortune?
Trying to open it up so I can.
Back in the early '80s, when I was working for was
What the hell?
selling these like word products. No, it's
Here we go.
Yep.
So if you want to show your viewers, they're just simple 2164 problems. and a broken case.
Yeah, this is a Fujitsu.
There you go.
Not much
They took their home
exciting,
computer
but
in Japan and they made a game console out of it.
Dump these off and then put them in something else, I guess.
Oh, no, I'm sorry.
yeah, or hey, with your luck, they're probably the same EEPROMs you'd find on a modem.
No, that's
Right.
That's a
Like, I don't know, a Hayes Smart Modem 9600.
Yeah, some ancient things. Cool.
Super fast. I remember when I got my 9600 baud modem, I was like, oh my god, what was I missing? 2400.
the tooling.
Oh, it was so slow. Upgraded to 14.4 and it was like a life of difference.
My gosh.
Somebody on the ThinkPad users group sent me their external modem. The 14.4 wasn't as reliable. But
Oh, interesting. Huh.
I remember hearing about VIS.
VIS. Would you say where?
I heard about this somewhere before.
That's what was supposed to be in all those boxes that computer reset.
Oh my gosh.
So I recently sold something from the Houston Museum that was it's a VHS cassette you put in a normal VHS player, but it would have data on both sides that you couldn't normally see on the screen. Oh, cool! And the console would kind of interpret that stuff depending on like however you answered questions. It was like Sesame Street type video, and it would have like a circle or a square, and it was kind of like interactive, but like the video was kind of set. I have to look it up. I literally just sold it on eBay like a week ago to somebody here in Fort Worth. But it was an interactive video concept that just didn't take off.
Virtually impossible to sell.
Oh, wait a minute. That's where I heard of VIS. Those boxes.
Yes, all those blue Zenith boxes.
And there's only one?
Well, this is the, it's branded Memorex, but this was the Radio Shack VIS.
But there's only one?
No, they made 11,000 of them.
But how many were a computer reset?
0.
So where the hell did you get this?
I've been collecting them for. But these are the Memorex version. The Zenith version never got produced.
That's why they have all those boxes.
That's why Richard has all the boxes, because that system never made it to market.
So I think you were there at the very end, but we actually ran out of those boxes at one point. I was amazed. Maybe within a couple of weeks of the end. Ran out. Yeah, I couldn't believe it.
There's still a ton of boxes there left in general, though. But
Well, but those particular boxes.
they're so convenient for stacking things. Oh my gosh.
Yeah. But here's the fun thing. So they never released the Zenith, but they did make a game.
That logo brings back so many memories of CR.
Does that look familiar? Yeah. So they made the manual, and they also made the manual in French, in case you wanted it in French.
Okay.
But they never. But they never released.
So I'm sure you grabbed a bunch of the little boxes, the mystery boxes.
Yeah.
Those are neat. I took a couple and I gave my daughter a couple of presents and I put them in the mystery boxes.
The other thing that was popular there, I'm gonna kill this real quick, were these. You saw tons of these there.
Okay.
At Computer Reset.
I think I recall that.
And they were for the VS.
So great.
So again, I'm thinking that I'm thinking that Richard just got, when they liquidated, Richard just ended up with everything.
Now, can you put that in any kind of other machine and read it?
Well, yes and no. The boot record on this is made for this. You see here it's saying insert a disk or cartridge. This has Microsoft Modular Windows in BIOS.
Okay.
The BIOS of it. So when this boots, it's looking for a boot record on it. And it's like an auto exec, but it's unique to the BIOS.
Okay.
So if your disk does not have that, you can't boot it here.
Right.
However, I could
Microchannel?
I'm sorry?
Microchannel?
Not
sure looks like it.
It sure does. I can't.
The microchannel connect. I'm being sarcastic.
Oh yeah.
Can't focus.
Oh well. It's something odd.
So what happens if you put that disk in like a PC?
Yes, then you can read it. And some of these
you can't execute the program.
Well, it depends on how the program is stored on the disk. Some of these, like Lynx, that obviously is available. I mean, you can get it out on Super Nintendo.
Okay.
So they've done a lot of copies of that. The demo disc actually has a program called Space Nuts.
Okay, so this was R&D for this, if they ran it on a PC.
Yes. So my next task is I've got a Tandy 3000. I'm going to put these into the Tandy 3000, install Microsoft Windows Software Development Kit,
And
PCMCIA?
no, these are all SM.
No, I mean, is this PCMCIA?
Oh, no, actually, it's not. It's
or is it like JEDEC? Oh, it's.
I can't remember who makes this.
Wow.
He's killed the machine. But it's a proprietary. I can't remember who makes that. 3Com or someone.
Oh boy.
But yeah, you have the developer cards. You build your code.
I'll get it.
Windows. If you have a program that does save games, they save to the disk or to the hard disk. So that's your memory. That's your composite and S video. And then this one is audio, just an Adlib Gold compatible audio card. All these were built by Tandy R&D, so you could build your own dev workstation. The three I don't have here. There's a modem card, because this also supports.
So these are development boards that were going to an industry standard PC.
To Tandy 3000.
All right, so this is not like an end user.
No, wow. Dev cards. So you could write your code.
They must be very rare.
Yeah. A few hundred of them, I think. I've got about 3 or 4 of each.
Wow.
There's not a lot of them. But you would write your code, and then the 2 cards I don't have here are the 3 cards. There's a fax card, fax modem. This is standard, Hayes compatible. There's the controller. This wired controller is a PS2 port, just a regular little DIN port or whatever it's called. And then the other is an RS-232 card that would go into your computer. And then they had a corresponding RS-232 card to go in the console.
Yeah.
So then when you write your code, you can actually push it out. So you could actually test
that's
it,
neat.
play test it in hardware instead of play testing on the PC.
Wow, that's pretty cool.
Wow.
And it was, it went Christmas '92, it went retail, and in 1994 they canned it.
Did they have any of this stuff at the Computer History Museum?
I don't know. You mean in Frisco?
Yeah.
Not yet.
Can't imagine.
Not yet.
It's going to be Mountain View, I'm sure.
1.3 second access time.
Oh,
Holy crap.
geez.
Yeah.
Even for single speed, that's bad.
It shipped with Compton's Encyclopedia, and they said it would take a minute and a half to load.
Oh no.
To get up. They built King's Quest for it from Sierra, King's Quest 5. It was almost a 5-minute load time, so they canned it.
Okay, this is 92.
That's terrible.
I'm honestly still surprised. I'm sure there was a big cost factor, but I'm still surprised that it used, like, say, a 386 SX16. Still would have been faster than the 286. And I mean, yeah, you save money, but I mean, still, the SX16 is still a piece of shit. 32-bit processor. I mean, it was, what do you call it? 32-bit internal, 16-bit. You already know. You already know the scoop.
No.
But I don't think there's that much of a cost factor. And I guess not to be an asshat on the purpose of them, but it's like, why did they use conventional motherboard instead of custom design this and just go that route? Except that how big would the cards be? Like you would think they would have saved R&D costs by using an off-the-shelf motherboard. Maybe have custom board for, I guess for memory. Have memory and EEPROM on one board, and then try to integrate as much as possible.
It's very interesting design and solution.
Yeah, because I would assume something like this would be somewhat considerable R&D to bring it to market, and then how long was it really that it really lasted in the market?
2 years.
That's not that long.
And most of them got sold.
Okie dokie. We are going to adjourn the live stream. Thank you so much for joining us, DFW Retrocomputing Meetup. And actually, you know what? Thomas, do you have the links available to power on?
Yeah, I do. I need to. Oh, actually, wait. Yeah, give me a sec. So.
This could be interesting to see.
Yeah, batteries. So. Well, we shall see. So, what we have right here is an Atari Lynx Fujinet. It has buttons for the 2 Fujinet buttons here, but it also has the USB for programming and a Comlinks port. Believe it or not, the network goes out here. And it goes into the Comlinks here. Now, to expedite things just a bit, what I'm going to do,
just bit banging across the headphone? I mean, that.
We actually use the serial port, but we configure the UART in just the right way that the Comlinks is happy with it. So what I'm going to do now, I'm going to swap out the memory card real quick.
Easy to lose.
Yeah. Well, I'm doing this because the network configuration is on this, is on here, and it will bring up quickly into the right mode here. Hopefully, see right there, we got a network connection. So now, if I, oh wow.
You gotta adjust your brightness.
Okay. So I'm gonna run ISS Lynx. And hopefully this will work. It's been a while since I ran this, so God only knows if this will actually work. Oh, come on. Really? You bastard. Try this again. This one's working. So it's misbehaving now.
Oh, no.
No, it's supposed to be an ISS tracker here.
Right.
Darn it. Oh well.
Is there something else?
No, not that I really have here that I can show. But I did the ISS port as a quick port. The thing about it is that the same firmware that runs on this guy, that runs on the Atari guy here, that runs on the Atom, that runs on this guy, they're all the same. The only difference is the bus interface. So if I had a way to pick and plug a keyboard for this thing, I could put an SSH client on it. For no other reason than I could. You know, just yay.
Just because you can, might as well.
Just because you can. Yeah, just because I can. I don't know. It may not work. It was worth a shot. I wasn't expecting to bring this guy out.
Gotcha.
But maybe.
I've seen it work.
Yeah, it does. Yeah, we had it working at the last meet just fine. I'm curious.
I wonder if there's an internet problem with this one or something.
I don't know. Maybe. But the light's on, which means it got a connection and it got an address.
So from your phone or what? From what?
From
the actual Wi-Fi here.
From the access point that's here.
Cool.
Does that make you a better phone maker?
So yeah,
this one?
Sorry, I apologize.
I am, and actually I should be using the gimbal instead of the tripod, but half of this was actually from the desk anyway, so it didn't really matter.
It doesn't look very fresh if you're not shaking the shit out of it.
Yeah, I know. Yeah, I need to put this back in, don't I? So, yeah, Fujinet for Lynx.
Nice.
We did actually, one of the other things that we did, for example, you saw some of the game lists in there, like Rampart and whatnot, Checkered Flag. We have a mode that basically takes and reflects Comlinks packets and Red-Eye packets across UDP, so that we can have a game go across the net. And it does it transparently. It's not perfect yet. We still need to optimize the speed of it and make it run as fast as it possibly can. But even at this stage, it's still very useful.
Were there multiplayer games?
Yes.
Okay. So there you go.
And the way you basically do that is you basically configure each participant in a ring. Player 1 connects to player 2, player 2, player 3, etc.
Sounds like the mini maze situation, I guess.
Yeah, just like you do on a real Comlinks.
Cool.
So
did you end up having?
Well, that's going to be it for the stream for sure. Thanks for joining us. We'll see you next time, whenever that might be.
So,
bye, y'all.
Long story short, pen mode.